Hi girls, hope all is well. Mr. Gilmore here, and I'm back with you. This is the 25th of March, area, perimeter, and volume. This is lesson 6. Last class we were talking about volume. We've done area and perimeter of a square. Now we're going to look at the surface area. What do we mean by surface area? Well, the surface area is the area of the surface of the object. So we figured out how much space this object takes up. Now what we're going to figure out is how much area is there all over this cuboid. So looking at this shape here, you will see there is our front face, our top face, this side face, and if we rotate it a bit, another side face here, another bottom here, and a kind of back face that we can see there, okay? So ultimately we've got 6 different faces, and I'm just going to draw in kind of, imagine we could still see the back of this cuboid here. Imagine you could still see the back. So we've got kind of this box in the back here, this rectangle at the back here, this rectangle at the front, this rectangle on the side, this rectangle on the other side, the top and the bottom. And we're just going to throw in some values here. We're going to go, okay, this is going to be our width, this is going to be our height, this is going to be our length, okay? So similarly, this line here, that's going to be our length. This side at the back here, actually, you know what, I'm going to write those in red. So at the back here, we can see that this red line here, this is also our length. You can see that this red line here is also our height, because it's kind of the height of the object. And this line here is the width. Okay, so let's count out these different sides, these different faces, and we will calculate from that what the total surface area of a cuboid should be. So if we're looking at this, we're going to go, okay, we've got our front face here, that's going to be 1. We've got our side face here, that's going to be 2. We've got our top face here, that's going to be 3. We've got our back face way at the back here, so the kind of opposite side to our front here, 4. You've got this side here, which is going to be the opposite to this side here, so that's going to be 5. And we've got the very, very bottom of the shape, 6. Okay, so we can see just in the same way that we would look at a dice or die. You know that it's a 6-sided die, so we're going to find the area of each face of this box. You know, pick up any box, you'll see, okay, it has 6 sides. We're going to find the surface area, which is just the sum of the area of all of those sides. So shape side 1, that's going to be width by height. Okay. Side 2 here, that's going to be height by length. So I'll do that again. Height by length. Side 3 here, the top of the box, that's going to be width by length. The back side here, that's going to be height by width. Or width by height in this situation. This side here, on our other side, that's going to be height by length. So you can see that there's kind of a box going on. 1 second. Box kind of going on here. That's going to be height by length. So I should be saying rectangle, not box there. So height by length. And then this final bottom end here. So our very, very bottom here. You see again, we've got another rectangle. And again, we're dealing with 3-dimensional objects. So the rectangles aren't going to be perfectly shaped out the way we would normally expect them to be. and that is going to be width by length. So let's find the surface area now. Okay, I'm actually just going to zoom in a little bit just to give myself a little bit more space. Get rid of that A, jot it down again. Surface area is going to be shape 1 plus shape 2 plus shape 3 plus side 4. I'm saying shape, I should be saying side, plus side 5 plus side 6. So let's turn that all into a little bit of algebra. So the width by the height is 1, plus the height by the length is 2, plus the width by the length is 3, plus 4 here, width by height, plus 5 here, and I'm just going to scroll down to 5, height by length, and finally width by length again. Okay. So I know this is very kind of abstract as an idea. Honestly, I'm regretting not being in a class with you guys right now, because it would make things just so much more clear to you guys. But what I'd actually suggest you do is I'd suggest you take out a box right now. Any old box will do. And you just measure the sides, right? Actually, don't even measure the sides. Just write in on each face of the box what kind of so label width, height, length, label each edge, whether it's the width, the height, the length, and then just write in whether it be width times length, width times height, and you will ultimately find that you'll get this formula again, okay? So the surface area of a cuboid is 2 times width by height, so the sum of the front and the back, plus 2 times height by length, so the sum of the area of this side plus the area of this side, and then the final part here, 2 times width by length, so the sum of the area here and the sum of the area here, okay? And that's just what that means. I'm going to give you guys a second. Draw yourself out a little cube. Let's actually look at some real examples, and once we see it in action, we'll understand why it's so valuable. So let's start with this shape here. Very, very simple, very like what we did last time. And again, what we're going to do is we're just going to draw in that unseen side for ourselves, just so that we can kind of conceptualize this, okay? So the surface area here, I'm going to zoom in a bit just so that we can give ourselves enough space. The surface area here is going to equal 4 times 2 to make up this side. So 4 times 2 is this bottom end, as is the top, 4 times 2. 2 times 10 is this side here, 2 times 10. And this side here, 2 times 10. And then the front and the back, we're going to jot that in as well. That's going to be 4 times 10 and 4 times 10. So we can either go, okay, 4 times 2 plus 4 times 2, so the top and the bottom added together, plus 2 times 10 plus 2 times 10, so these two sides added together, plus 4 times 10 plus 4 times 10, so the front and the back added together. That's fine. Other option here, I'm just going to write in or here. Or we can go, okay, using our formula, 2WL plus 2HL plus 2WH. So 2 times 4 times 2 plus 2 times 10 times 2 plus 2 times 4 times 10. Okay, and you'll notice, wait a second, here we have 2 4 times 2's, and here we have 2 4 times 2's. Here we have 2 10 times 2's. Here we have 2 10 times 2's. And here we have 2 4 times 2's, 4 times 10's. Here we have 2 4 times 10's. So regardless of which one you do, you can complete that out. So you might be wondering why I am just teaching you one method, or I'm not just going, okay, do this method or do this method. This one's probably a bit easier when we're dealing with a normal cube, and I'll explain that in a second. But either way, you'll realize these two values are the same. They're the same value when you actually sit down and do the equation. So I'm going to say just use your calculator for this. It's not one of those tasks that I would expect you guys to just be spending huge amounts of time doing out the calculations. And you're also more likely to make a little error that way. So when I throw that all into a calculator, I end up getting 136. Now here's the question. What unit is that? Well, we're just looking at the surface of the object, right? We're looking at the two-dimensional value of this face, the two-dimensional value of this face, the two-dimensional value of the back, the two-dimensional value of the front, the two-dimensional value of the top, and the two-dimensional value of the bottom. So because we're keeping two-dimensional, we're just going to say centimeters squared, right? Because we're actually just looking at the square faces of this box. Okay, I'm going to teach you guys one more little thing. And we're just going to scroll over to this side here, okay? So you can see here we've got another unusual shape. Because you all know I love unusual shapes. So, just bring that up a little bit, just so that we have enough space. Zoom in a little bit as well. Oh, 1 second. Okay, so here we want to find out the surface area of this object, okay? So we have got something that has height and width, but it's 3 blocks put together, right? So if we were to imagine the other side of this, and I'm going to butcher this now that I have to draw on camera. There we go. There we go. Okay, so you can imagine this other side. So these are the sides that we aren't seeing, okay? So this face here, that's between this first block and this back block. The face between the two, that's not there. Similarly, with these two, the face between these two, that also isn't there. So if we think about how many sides are going to be on this, we have 1, 2, 3, 4, 5, and then we don't have that face. We've got a top face of the back block, the 2 back faces, and the 1 bottom face here, right? But that's the thing. We don't have the 2 front faces for that back block. Finally, we can also look at this block here. So we can see that there's a top one, there's a front one, there's a bottom one, there's this other front one, and then there's a back one. That's going to be it. So if they were to go, okay, what's the surface area of this? We can say, okay, every square here is 2 by 2, right? So every square has an area of 2 times 2, so it has this area of 4 centimeters squared. And we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 faces. So there's 14 faces on this. So instead of us doing what would be 3 times 6, which would be 18 faces, we've got 4 less faces here. So we have to go, okay, this here, each square multiplied by 14. So we've got 14 faces. So it'll end up being, 4 times 14. So that would end up being 4 times 14. That would be 56 centimeters squared. Similarly, if I had, let's say, instead of me doing a shape like that, I had a load of blocks rowed up together, okay? All of them just put together like so. So 1, 2, 3, 4, let's say 4 faces. You know, let's go for broke. Let's go for 5. Okay. Then if we were looking at that, we could go, okay, there's 1, 2, 3, the bottom one, the side one. Then each of these middle ones would have 4 faces because the front and the back faces are covered. And this one has 1, 2, 3, 4, 5. So we'd have 5 and 5 and 3 sets of 4. So that would actually only have 22 faces. Now, if you have any trouble with this kind of concept, feel free to contact me. I know it's a little bit more abstract. It is one of the kind of tougher questions. I'll show you the full set of what we've done today. And I'm also just going to set you guys a little bit of work here. So again, on pages, just making sure I've got the correct pages here before I set anything out. Okay, 208, 209, and let's say 210. Can we do questions 2, 3 part B, 4, 6, 7 part 2, 9 part 2, 10, and 14. And these two values here, these two questions, I'm going to say these are tough ones, so we need to show our work for these two at least. Anyway, girls, hopefully you guys have a little bit of fun with this. Feel free to contact me if you have any trouble with these questions. And I hope you all have a wonderful day. Bye-bye.